Hey there everyone, this is Aniket Patro. Welcome back to my YouTube channel, and in this video we are going to discuss about the topic that is modeller. In this video we are going to discuss about the insights of the topic that is modeller and its use cases and the applications of the modeller application, and that too we are going to use the practical demonstration to understand the insights of the modeller application. Assume a scenario. If we download a protein structure from a local PDB databases, and if the PDB databases or the PDB structure have any type of missing residue in it, it will be an unideal characteristics, right? So to overcome this type of situation, we are going to use the modeller application. As the protein structure has been visualized using NMR or XRD, so with a certain type of resolution, it may be have some type of hurdle, like the some part of the protein structure has not been captured using the XRD or NMR. To overcome this type of situation, we are going to use the application modeller. So without wasting any time, let's move to the computer screen and let's start the practical demonstration. So initially we have to download the protein structure, and so let's move to the Google Chrome or any type of browser that is available. So we have to download the modeller application. So for that we have to write the modeller and click on here, and then after we have to go to this step and download this application using the browser. So after downloading and choosing any type of requirements in the applications, so after the downloading you have to save in the C drive, and then after let's move to the PDB databases. So before going, let's type the PDB databases, and here we will find the RCSB PDB homepage. It is the homepage of the protein structure and whole of the repository contained in this type of databases. For our own convenience, let's start searching for the cancer protein. Let's click the quote here. After clicking the search ID here, we are going to filter it by Homo sapiens, and that too we have to choose the resolution between less than 2, so it will be more fine, like 0.5 to 0.9. and see we have been find this type of protein structure, that is 65ZK. This is the PDB ID of the protein structure. Let's click inside it, and then after we'll going to visualize the whole repository and the protein structure, and it include some type of experimental data snapshot, that is this protein has been visualized using the X-ray diffraction and with a resolution of 0.99 angstrom, and the R value for this protein structure is 0.143, and for the work it is 0.124, and the observed is the 0.124. and here we will find the macromolecular content, that is a structure weight of 29.55 kDa and more on. So there is a single chain, and this protein contains only a single chain, so it will be a best type of protein to have a practical demonstration. Then we have to click on the download files. Initially we have to download the PDB format, so let's click on there, and then after we need a FASTA sequence, that too. I will going to explain why we need this FASTA sequence. After that let's store that sequence in the file. For that we have to click here and create a alignment file, and we have to save it here. And after the saving of the file, we have the protein structure, so we can visualize it using the resmol for now. And this is the protein structure, and it has been predicted or analyzed using the XRD, and you will find the FASTA sequence here. And we need total of 3 type of scripts, but for our own convenience we have taken the 2 scripts, and later on we will going to use the scripts. So let's click on the script1.py, and here you will find this is the code for the script1, and it uses the modeller application to get the information and imported all type of library using the modeller. So the code will be qpdb. We are going to rename the file. So as we know that the code is equal to qpdb, this is the file name. So before going to that, let's click on here, and the protein structure should be renamed as qpdb. If you didn't want to rename this protein structure, you simply change over here. So the code equal to the protein PDB ID, it will be up to you. Like for the best protein structure or for any type of convenience, you can write your PDB ID here or the file name here. Then after we have checked the file, and then after let's move to the script2.py and let's see, visualize. Okay, it has been visualized. Now now this folder contain the script1 file, the script2 file, and that to the FASTA sequence and the qpdb.pdb. Now the next task of the protein is, let's copy this folder, that is the modular repair folder, and then after we have to move to the C drive. Here you have to go to the program files and you have to search for the modeller. So here you will have to find the modeller application, that is modeller 10.8, and you will find the bin section here, and then after you have to simply paste the folder inside this, and you have to give the administrator permission to complete the task. After pasting the folder here, now click on the file folder, and then after you will find the qpdb.pdb, rcsb, and script1.py, script2.py. Now we are going to launch the modeller applications using the search icon. Now you have to click here and type modeller. So after that you have to run it as administrator, because the C drive needs an administrator permission to do it. So click on here and let's give me permissions. Okay, now the permission has been granted. Now let's start with the icon. Okay, so the default path of this protein structure has been selected in the modeller 10.8. so we have to move to the bin folders. To write that, you have to hit the command cd bin and you have move to the bin folder, and then after we need let's check the directory what we have, and for that we need the modeller repair folder inside it. So we have to move to this file. So for that you have to again write cd modeller and modeller and the folder name, that is modeller repair, and successfully we have moved to the modeller repair folder. Let's check the directory and you will find the directory which the script files has been contained, and then after we have the qpdb.pdb file inside it. So we are ready for that, and we have the script1.py inside the folder, and let's hit the command, that is mod 10.8. This is the version of the file, like this is the modeller 10.8, so the version should be written here, and then after we have to write script1.py. then after we have to hit the enter button. After hitting the enter button you will get a log file, and you will find a .seq file. That this .seq file is an important file to check the content as it grab the details from the qpdb.pdb data file, and from the, so let's visualize the qpdb.sequence file. We can visualize it using the notepad. So this is the sequence of the .seq file. This is the sequence, and okay, now let's check for the next file. So before going to the next step, let's visualize the qpdb.pdb file inside the WordPad. So you will find the different type of remark and the source, and we have to find the missing residue. Now click on the Ctrl F and find missing residue, and you will find the missing residue over here. So this will be the missing residue. Okay, let's try another time. Okay, so here are the following missing residue, and it has been noted from like the sequence 1, 2, and 3 has been missed, and for that you will find the missing residue from the remark 465 to here, and you will find the META, and the C indicates the chain, that is A. So this indicates the chain of the respective amino acid which has been mixed using the different XRD or NMR, and this 3 amino acid has been not recognized. So we will gonna fix this 3 type of sequence in the modeller applications. After visualization, and you will going to find the qpdb.pdb, and after the running successful running of the script1.py file, you will find a .seq file, and that too a log file. So after hitting the .log file, you will find there will be a modeller 10.8 and its version, and it will get you some type of insight and its information. Then after, as we have clicked on the script1.log file, and then after we have got the qpdb.seq file, the next step is to create the alignment.ali file. For the alignment file, we need .seq sequence, and that too the FASTA sequence. And before going to the next step, we have to use the application or the website, the EMBOSS Needle, for the pairwise sequence alignment. For that, we also need the .seq file and the FASTA file. And let's click on the seq file using the notepad. So this is the .seq file. We need the sequence. Before going to the sequence, we will going to the browser and let's read the EMBOSS Needle here. Let's click on the EMBOSS Needle, and this will redirect to the page where we are going to have PSA, that is pairwise sequence alignment. Let's wait for this. Okay. Finally, the website has been refreshed, and here you will find an interface naming EMBOSS Needle, and you have to go to the tab that is pairwise sequence alignment, and you will find the sequence type. It should be protein, and you have to drop the first sequence here and the second sequence here. For the first sequence, we have to refer the .seq file, and we have to copy this content from H to K, and we have to copy this, and then after paste this here. And after pasting the sequence, let's rearrange the data by clicking on the N, and now okay, the first sequence has been registered here, and for the second sequence we have to refer the .fastaq file, and we have downloaded the fastaq file inside here. So let's click on here and redirect it using the notepad, and we have to copy the content of the sequence from here to here, and let's click on the Ctrl+C, and then after we have to move to the website and paste the sequence over here, and this will take a small time and to get the result. Then after we have to get a title for this. For my own convenience, I am giving modeller sequence. Now your result has been submitted, and your job will be going to run in the databases. After the result, you will find the page over here. Finally, the job has been completed successfully, and the result for the job will be loaded here. And for that, you have to wait for the loading. So the result has been loaded, and you can download your the tool output over this button. And then after, we have to go to the sequence, and here you will find the comparison, like the PSA pairwise sequence alignment between those two sequences, and you will find there is no missing residue over here, but the missing residue which is present is from 1, 2, and 3, which we have find using the WordPad also. So we have to note these 3 type of dashes over there, and let's go for creation of .ali file. So for this, we have to go to the modeller repair folder, and you have to construct the .ali file. For that, I have a file naming that alignment.ali. So we have to click on open using the notepad. After opening this, we have to paste the first .seq file over here, and then after we have to paste the FASTA sequence over here. So we have to first load the qpdb.sequence, and then after we have to copy the whole content. Let's click on the copy, and now we have to use the alignment.ali file. Now paste the sequence here, and then you will find there is an interface. Okay, let's clear the spaces. Okay, now we have done successfully, and then after we have to load the FASTA sequence over here. For the FASTA sequence, we are going to refer this, and we need to copy this content only. Now click on the copy, and now we have to click here and now paste the sequence over here. And finally, .ali file has been constructed successfully. Now click on Ctrl+S for saving this file. After saving the file, we have to copy this file to the bin folder. For that, we have to click on the Ctrl+C, and let's move to the modular repair folder, that is inside the bin folder. Now paste the ALI file over here, and we have to get the administrator permission for that too. Hence we have copied the file and we have pasted the whole alignment.ali sequence over here. And then after, the next task is to run the second script, that is script2.py. For that we need to go to the modeller CLI, and now we have to hit the same command, that is mod 10.8 script2.py. Finally, let's click on the enter button, and it will take some type of time and it will execute, or it will create new type of file over there. So our script2.py file has been clicked, and you will find there are multiple files has been registered here. So for let's rearrange the file. To find the appropriate protein structure, we can refer that log file of the script2. So click on the log file and visualize it using notepad, and we have to move to the downward, and you will find there is a section named mol pdf, and you will find the file name and its mol pdf. So there is a two type of score from each of the PDB structure, that is the change is here, like it has been 1 and it is the second file. So the lower the score of the mol pdf, the highest or the best the protein or structure will be. So now we have to ready for the next script, that is script3.py. For that we have to go again this script3.py, and we have to make some appropriate changes over here. We have to open this structure using the notepad only. Open with notepad, and you will find there is a different type of code over here, and as for our own convenience, and we know that we have a residue range from 1 to 3. You will find over here, like from 1, sequence 2 and sequence 3, the 3 daces are visible. It means this much of sequence is unknown for us, and it need to be filled. So let's minimize, and we have to give the range between 1 to 3. So we have to remove this part as well as, and now for that we have to use from sequence 1 and to sequence 3. So I have an so now the appropriate changes has been done. Now we have to click on the save button, and after clicking on the save, let's close the notepad. Now we have to copy this script3.py folder inside the modeller repair folder. Now we have to paste over here, and now give the permissions. After the running of the script2, and we have to now execute the script3.py by following conditions only. But the script3.py files use and refine the model more and more appropriate, and the script2.py, the 4 PDB structure will be get refined using the script3.py, using the script3.py structure. Let's go to the modeller CLI and now execute this next script, that is mod 10.8 script3.py. Now after clicking this, let's click the enter button. It may take some type of time, but the result will be get more and more precise. So the script3.py file has been done successfully. Let's visualize the structure using the PyMol. We have to launch the PyMol applications, and we have to open this folder. We have to open this file and the qpdb.pdb file, that is a raw file. Let's see the difference, and let's notate the difference among them. So we have been loaded the whole PDB structure using this PyMol. Let's wait for that. Okay, now we have been loaded the PyMol. Now we have to load the next file, that is over here, and we have to go to the drive C, and we have to go for the program files, and we have to find the modeller. So for the modeller, we have to go to the bin folder, and for the modeller repair. So initially we have to visualize the raw PDB file. Now click on the qpdb.pdb file. Now let's go for the visualization of the protein structure. Now you have to go to the raw file, that is qpdb.pdb file. We have to open this file, and you will find there is some type of noise. That's not the noise, that's actually the water molecule which is present over there. And we can remove the water molecule using the action tab, and there is a co-crystallized ligand over here also. So now clicking on the action, now we can remove the water. The red color content has been removed. Now you can display the sequence, like, and for the sequence mode we will choose the residue name. You will find there is the sequence start from 4, and we have known that the sequence should be have 1 2 3, that 3 sequences are being missed in this structure. But we have created, or we have constructed the protein structure that contains sequence 1 2 3 as well as. So for that we have to click on the open. Now we have to find the B999 this file. Now click on the open. You will find there will be small type of mess over here. So to fix that, we have to hit the command over this Sierra window. For that we have to click align. Now write QPDB and let's click on the tab, and then after we have to go for the comma, and you have to write this file name. This is QPDB. That we have to copy this content, and then after we have to click on the enter. Now clicking on the enter, you will find the whole protein structure, or the whole mess has been removed. And let's find the difference over here. You will find the modeler created. You will find the difference over here, as we have created this file using the modeller application. So the sequence starts from 1 2 and 3, and these 3 sequences are absent in the raw PDB file, that is from 4 to 6. As we know that HIS TRP GLY has been started over here, that is 4 5 and 6, but the first 3 amino acid has been missing over here. Now let's zoom this file and the structure, and let's find the difference over there. Okay, now I have zoomed this appropriate structure, and you will find the green color line which has been missing. That is a raw protein structure from it has been stopped here, but the new protein structure which has been created using the modeller application, this is the amino acid. Like this 3 amino acid has been redesigned, and now it is being ready for the next step, that is for the molecular docking and the molecular dynamics. For this video, it is completed all over the modeller applications overview, their applications, their workflow, their pipeline. I have discussed all over the practical demonstration, and we can also use this structure in any type of dynamic studies and different type of application. It is done for this video, and if you like this content and if you like this tutorial, so please hit the like icon and the subscribe icon and press the bell icon for the next notifications. Please subscribe and please like this video. For this, signing out, Aniket Patru.